In this video, I will explain pin and functional block diagram of IC 555 timer. 555 timer has 8 pins. Pin 1, 2, 3, 4, 5, 6, 7, 8. Pin 1 is meant for ground. 2 is trigger. 3 is output. 4 is reset. 5 is control voltage. 6 is threshold voltage. 7 is discharge. 8 is VCC. These are the 8 pins of the 555 timer IC. Next one is functional block diagram. This one is the functional block diagram. This block diagram consists of internal block diagram of 555 timer IC consists of two comparators. This one is threshold comparator 1 and comparator 2. Comparator 1 is called as a threshold comparator. Comparator 2 is called as a trigger comparator. Comparator 1 is also called as non-inverting comparator. Comparator 2 is called as inverting comparator. Comparator 1 is called as non-inverting comparator because threshold voltage is applied to sixth pin. Sixth or non-inverting terminal of the comparator 1. Comparator 2 is called as inverting comparator because trigger voltage is applied to second pin, that is inverting terminal of the comparator 2. Two comparators. Next one, voltage divider circuit. This is 3 equal resistances R, and R. Generally, R value is 5 kilo ohms. R value is equal resistances 5 kilo ohms. This one is VCC is applied to voltage divider circuit. R. This one is R and this one is R with respect to ground. This one is find out these two voltages with respect to ground. This one is with respect to ground. Find out this voltage. That voltage is at fifth point. Fifth one. This one is this point. This voltage, find out this voltage across R is V2 comparator to V2 plus, that is equal to V2 plus is equal to VCC into R by sum of these three resistances 3R, that is equal RR cancelled, VCC by 3. This point is VC by 3. This voltage is comparator 2 plus. This one is comparator 1 minus, or fifth pin of that 555 timer IC. V1 minus is equal to these are the reference voltages. VCC into, with respect to ground, R plus R. This voltage is R, this voltage is R, 2R by sum of these three resistances. R cancelled, therefore this voltage is 2 by 3 VCC. At this point, the voltage is 2 by 3 VCC. This is the inverting terminal of that comparator 1. At this point, the reference voltage is 1 by 3 VCC. This one is a non-inverting terminal of the comparator. This is the description of voltage divider circuit. Next one, RS flip-flop. This one is a flip-flop SR flip-flop. S is equal to 1, Q is equal to 1, S is equal to 0, Q is equal to 0. Set and reset the flip-flop conditions based on the output of the comparators. This one is the discharge transistor. Discharge. transistor T. Their discharge transistor T collector is connected to 7th pin of the 555 timer IC. Output of the flip-flop, that is Q, is connected to base of this NPN transistor through resistance R. These are the basic components of the 555 timer internal structure. Two comparators, non-inverting comparator and inverting comparator, and voltage divider by a circuit. 3 equal resistance are there with VCC and one flip-flop and discharge transistors. These are the important elements of the 555 timer IC, internal components. Coming to description of that one, the IC comparator names as a threshold comparator and a trigger comparator. This was comparator 1. This is comparator 2. Comparator 1 is also called as non-inverting comparator. Comparator 2 is called as inverting comparator. Comparator 1 is also called as a threshold comparator because threshold is applied to plus, that means non-inverting terminal of this comparator 1. That is the reason it is called as threshold comparator. Second one is called as a trigger comparator. Trigger voltage or pulse, trigger pulse is applied to inverting terminal of the comparator 2. A threshold comparator is non-inverting and it has a reference voltage 2/3 VCC. This is the reference voltage. Reference voltage. The pin number 6, that means threshold input, is the input terminal of the threshold comparator. That means plus non-inverting terminal of the comparator. When the threshold voltage is greater than the reference voltage, that means threshold voltage is greater than reference voltage is 2/3 VCC. It produces high output. Because why? Because this produces high output means, that means 1. When threshold voltage is applied at the non-inverting terminal of the comparator 1 and 2/3 VCC, the reference voltage, is applied at the inverting terminal of the comparator 1. Compare these two. Threshold voltage is at positive level and 2/3 get connected at a negative. Therefore, whenever threshold voltage is greater than 2/3 VCC, therefore output of the comparator is high. When the threshold voltage is greater than the reference voltage 2/3 VCC, it produces high output voltage. Okay. When the threshold voltage less than 2/3 VCC, less than reference voltage, that is 2/3, it produces low, that is 0. Coming to comparator 2, the trigger comparator is an inverting comparator. And has a reference voltage like comparator 1. Reference voltage here is 1/3 VCC. This is the reference voltage. Again, comparator means compare the two voltages which are applied to inverting and non-inverting terminals of that op-amp and produces output based on the condition. Which one is higher? Higher value produces at the output of the comparator. The trigger comparator is an inverting comparator and has reference voltage 1/3 VCC. Reference voltage is 1/3 VCC. The pin number 2 trigger input is the input terminal of the trigger comparator. Here pin number 6 is the threshold input of the non-inverting comparator. Like that, pin number 2 is the input terminal of trigger comparator. When the trigger voltage less than 1/3 VCC, it produces high output voltage because 1/3 VCC is connected to positive value. Therefore, positive means trigger is level trigger voltage or trigger pulse is connected to negative terminal of the inverting comparator. Therefore, 1/3 VCC is greater than trigger. That means 1/3 is at positive level, positive terminal connected to positive terminal. Therefore, inverting comparator output is 1. When the trigger voltage is less than reference voltage, it produces high output voltage. When trigger voltage is greater than 1/3 VCC, that is reference voltage, it produces low output voltage. It produces low output voltage. The output of the both comparators are given to the RS flip-flop. Non-inverting comparator output is connected to S, and inverting comparator output is connected to R. These are the inputs of the SR flip-flop. These are the inputs of the SR flip-flop. Coming to next one, RS flip-flop. The description of that two comparators completed, non-inverting comparator and inverting comparator completed. Next, RS flip-flop. It consists of flip-flop which is similar to normal type RS flip-flop, which follows the input and output. Okay. The output of the threshold comparator is connected to S input. This is the output of the threshold comparator, means comparator 1 is connected to S input of the flip-flop. This is the S input of the flip-flop, and the output of the trigger comparator is connected to, that means inverting comparator is connected to R input of flip-flop. This one is R input of flip-flop. It has two outputs, Q and Q dash. Q and Q dash. When the threshold input, this one is the concentrate on this one, non-inverting comparator, that means comparator 1. When threshold input voltage, this one at 6th pin, is less than the reference voltage 2/3 VCC, the threshold comparator produces low output voltage. The comparator produces low output voltage. It means S input of flip-flop, S is equal to 0. Here, when the threshold input voltage is less than the reference voltage of 2/3, this one is a threshold. And threshold input voltage is less than the 2/3 VCC. That is output of 2/3 VCC. This is the low value. Positive threshold value, low value. 2/3 VCC is the high value. Therefore, the output of the comparator 1 is non-inverting comparator is 0. S is equal to 0 means Q is equal to 0. Q dash is equal to 1. Q dash is equal to 1. When the threshold input voltage is less than the reference voltage, the threshold comparator produces low output voltage. That means 0. It means S input of flip-flop is low. S is equal to 0. Okay, when one condition. And when the trigger input voltage is less than the reference voltage, coming to this one, trigger, when trigger input is less than 1/3 VCC, is less than the reference voltage, the trigger comparator produces high output because 1/3 VCC is connected to positive, trigger is connected to negative terminal of the inverting comparator. 1/3 VCC is greater value, therefore inverting comparator produces high value. When the trigger input voltage is less than the reference voltage of the reference voltage, that means 1/3 VCC, the trigger comparator produces high output voltage. This means R input of flip-flop is high, that is R is equal to 1. Therefore, the flip-flop gets in reset condition and produces the flip-flop gets in reset condition and produces the outputs Q is equal to 0 and Q dash is equal to 1. Q is equal to 0 and Q dash is equal to 1. When threshold voltage, consider non-inverting comparator, threshold voltage is less than 2 by 3 VCC. Consider inverting comparator. Trigger voltage is less than 1 by 3 VCC. Therefore, the flip-flop gets in reset condition and produces the outputs Q is equal to 0 and Q dash is equal to 1. Coming to this one, in threshold voltage greater than 2 by 3 VCC and the trigger voltage greater than 1 by 3 VCC. When the threshold input voltage is greater than the reference voltage, that means 2 by 3 VCC, the threshold comparator produces high output because the sixth pin of that IC is connected to inverting, non-inverting terminal of that comparator 1, that is at positive. Therefore, that value is high. Therefore, comparator produces high value, that is S is equal to 1, Q is equal to 1. When the trigger voltage is greater than the reference voltage, that means 1 by 3 VCC, the trigger comparator produces low output voltage are equal to 0. Therefore, Q dash is equal to 0. The flip-flop gets in set condition. And produces the output Q is equal to 1 and Q dash is equal to 0. SR flip-flop 0 memorized. 0 1 0 1 1 0 1 0 1 1 not recognized. The flip-flop output Q is connected to, this one is Q. Q is connected to base terminal of the transistor through R, and output is taken outside. An actual output pin is 3. Actual output pin is, this one is 3. In this diagram, the actual output pin is 3. Output pin is 3 here also. The output pin is 3. The flip-flop output Q is connected to base terminal of transistor, and output is taken outside as an actual output pin number of the IC 555 timer. Actual output is 3. Discharge transistor. Coming to this transistor is called as a discharge transistor. Output pin is 3. The flip-flop output Q is connected to base terminal of the transistor called a discharge transistor. This one is discharge transistor. When the flip-flop is set condition Q is equal to 1, this one is Q is equal to 1 means that S is equal to 1, R is equal to 0. S is equal to 1 means the threshold voltage is greater than the control voltage because the threshold is at a positive. Come 2 by 3 VCC is at negative terminal, connected to negative terminal. Therefore, compare this one. Threshold voltage is greater than trigger reference voltage 2 by 3 VCC. The output of that non-inverting comparator is 1. Q is 1. That is Q is 1. This one is NPN transistor. Whenever Q is 1, Q is equal to 1, transistor base terminal goes high. This is the base is connected to 1. That means transistor's base terminal goes high and it operates in saturation region. Condition. Therefore, the transistor works as a closed switch and provides a charging path for externally connected capacitor through it. Suppose here the capacitor is connected here. Suppose whenever a capacitor is connected here, Q is high. The transistor is in is in forward bias condition. That means acts as a closed switch. The transistor works as a closed switch and provides a discharging path for externally connected capacitor to it. For discharging path, this one is acts as closed switch, short circuit. This is the collector of this transistor. Collector of this transistor is the discharge terminal of the 355 timer IC. Discharge terminal of the 355 timer IC. When the flip-flop is reset, that is equal Q is equal to 0. The transistor base goes low. This one is low and operates in cutoff region. The transistor works as a open switch. In the previous case, it acts as closed switch. This one is open switch. Open switch. Therefore, the transistor is disconnected from this terminal and the capacitor is charged. The transistor works as an open switch and does not provide any discharging path for externally connected capacitor. This one through it. So the capacitor charges towards VCC. Therefore, VCC is directly connected to discharge terminal of the 355 timer IC. That is very, very important. Based on that Q value, Q is equal to 1. The transistor is in saturation, operates in saturation region, acts as closed switch. It provides a discharging path for the externally connected capacitor to the 7th pin of the 355 timer IC. When Q is equal to 0, the transistor is operated in cutoff region. It acts as a closed switch. It does not provide any discharging path to the externally connected capacitor. Therefore, it is disconnected. It is disconnected. Therefore, the capacitor is charged towards VCC. Next one, voltage divider. Voltage divider forms by using series combination of resistances. This one is resistance 1, resistance 2, and resistance 3. This is the voltage divider by a circuit. A plus VCC is applied here. This is the plus VCC. Find out this voltage with respect to ground and this voltage with respect to ground. This voltage means VCC into R plus R with respect to ground. This one is with respect to ground. 2R by 3R. 2 VCC by 3. Here, this voltage is VCC into R by 3R. That means VCC by 3. This means VCC by 3. This voltage is 2 VCC by 3. These are the 2 VCC by 3. Here 2 by 3 VCC is connected to inverting terminal of the threshold comparator. 1 by 3 VCC is connected to non-inverting terminal of the trigger comparator or inverting comparator. These are the description of the internal components of 355 timer IC. Next one, functions of pin terminals of 355 timer IC. Pin 1. This is the pin 1. Pin number 1 is ground terminal. This is the ground terminal. All the voltages are measured with respect to this terminal only. All the voltages are measured concerning this terminal. The negative terminal of power supply or battery is connected to this pin. Any battery, suppose here 5 volts is there. 5 volts negative terminal is connected to this ground terminal. Any voltage is measured with respect to ground terminal. Ground terminal is nothing but the reference terminal. This one is ground. Trigger. The pin number 2 is the trigger terminal, is the input voltage terminal of the inverting comparator. Input voltage terminal of the inverting comparator. When trigger voltage is slightly less than 1 by 3 VCC, that is a reference voltage, the internal RS flip-flop changes its state. So the output of the IC355 depends on the trigger terminal voltage. This is the output terminal is 3. The output of the trigger terminal is totally depends on the output of this 355 timer IC totally depends on the trigger voltage is applied at the non-inverting terminal of the inverting comparator. Pin number 3. This one is pin number 3 is the output terminal. The output of this IC can be obtained in two ways between pin number 3 and the ground, this one, and also between terminals pin number 3 and the plus VCC, and also between this terminals pin number 3 and plus VCC. Next one, pin number 4. This is the pin number 4, reset pin. When the reset pin is grounded, that means connected to grounded, it prevents the device from working. It creates some interruption to that working of that 355 timer IC. This is also called as interrupt pin. When the reset pin is grounded, it prevents the device from working. Therefore, generally it is connected to plus VCC. Generally it is connected to plus VCC. A timing interval may be changed by connecting this pin to the ground, but the timing of the output pulse does not start again until the voltage across reset pin above approximately 0.7 volts. So avoid accidental reset of 355. Reset pin always connected to ground. Reset pin always connected to ground. Next, pin number 5. This one is pin number 5. Pin number 5 is the control voltage, control pin. Override this this control voltage overrides this reference voltage 2/3 VCC. In most of the applications of IC355, the control pin is not used. Control pin is not used. Therefore, control voltage is at 2/3 VCC reference voltage produced by the potential divisor as remained using 3 resistors. These are 3 resistors of value 5 kilo. Each value is same 5 kilo ohms. 2/3 VCC produced due to that potential divider arrangement. Therefore, control voltage is at 2/3 VCC reference voltage produced by that potential divisor as means using 3 resistors of 5 kilo ohms. A resistor or potentiometer between pin number 5 and ground, a potentiometer ground. Generally, by connecting a resistor or a potentiometer between pin number 5 and ground, pulse width of output voltage. Suppose a pulse is produced by using this one. This is the width of the pulse. The pulse width of that voltage can be varied by using this arrangement. When not in use, the control pin is bypass to ground. Suppose this control pin is not used, bypass to ground with some capacitor. With a capacitor 0.01 microfarad. Avoid disturbances. By using a potentiometer between this the control pin 5 and the ground, varying this one potentiometer, the width of that pulse produced at the output of the 355 timer is changes. And also, so in order to avoid some disturbances, the control pin is connected to ground through some capacitance value 0.01 microfarad. Coming to 6th pin. Pin number 6 is the threshold voltage. When the voltage at this pin is slightly greater than 2/3 VCC, the output of IC is low. That means SC is equal to 1, Q dash is low. That means Q is equal to 1. Obviously, invert of Q is Q dash is 0. Therefore, the output of IC is low. That means 0 means the output of IC is low, appeared at the 3rd pin. So the output of IC355 also depends on the threshold terminal voltage. Pin number 7, discharge, very, very important. The pin number 7 is discharge pin. It is connected to the collector. This one is collector of discharge transistor. When the flip-flop is set to 1, the transistor is on. This one is the transistor is on because base is positive. High value drives this transistor is in on condition, moves towards the saturation region, and provides a discharge path for capacitor connected externally. Discharge path. Pin number 8 is VCC. Pin number 8 is the VCC terminal. The positive terminal of a power supply or battery is connected to this pin. Positive terminal of the power supply battery. Generally, that voltage, battery voltage lies in between 4 volts to 16 volts. The operating power supply is connected in between the pin number 8 and pin number 1. This is the description of the pins configurations and the internal components of the 555 timer IC. The internal components of the 555 timer IC are comparators, two comparators. That is threshold comparator, threshold comparator. Second one is a trigger comparator. Trigger comparator. Threshold comparator is called as a non-inverting comparator. Non-inverting comparator. Trigger comparator is called as inverting comparator. Inverting comparator. Inverting comparator. Second one is SR flip-flop. Third one is this is the control element. Control the operation of the 355 timer IC. Third one is discharge transistor. Discharge transistor. Fourth one is voltage divider circuit. Voltage divider circuit. Totally 8 pins are there for the 355 timer IC. With this, the pins description and the internal components analysis explanation is also completed.